Hello everyone. Today we are starting section 3.3, Differentiation Rules. In the previous sections, we learned how to compute derivatives using the limit definition. The limit definition is very important because it shows us what a derivative really means. However, using the limit definition can be slow and time-consuming. So in this section, we are going to learn some rules that help us compute derivatives much faster and more efficiently. These rules will make taking derivatives much easier, especially for more complicated functions. Let's begin with the basic differentiation rules. There are two very important rules that we will start with: the constant rule and the power rule. First, let's start with the constant rule. Let C be a constant. This means the function does not change. It stays the same no matter what value of x we choose. If f of x equals c, then the derivative f prime of x equals 0. So the derivative of a constant is 0. Why is that? Remember that the derivative represents the rate of change or the slope. But if a function is a constant, it does not change at all. So the rate of change is 0 and the slope of the graph is 0. So we can summarize the rule like this: the derivative of a constant is 0. Now let's talk about the power rule. Let n be an integer. If f of x equals x to the n, then the derivative f prime of x is n times x to the n minus 1. Let's talk about what happens to the exponent. Two things happened. First, the exponent becomes the coefficient. Second, the new exponent is 1 less than the original exponent. This rule is extremely important and we will use it very often. Let's look at our first example. We want to find the derivative of the function f of x equals x to the 10th. To solve this, we will use the power rule. The power rule tells us f prime of x equals n times x to the n minus 1. Here, the exponent is 10. Step 1, the exponent becomes the coefficient. So we bring the 10 to the front. Step 2, subtract 1 from the exponent. So we have f prime of x equals 10 times x raised to the 10 minus 1. And 10 minus 1 is 9. So we have 10 times x to the 9th. And this is our final answer. So the derivative of x to the 10th is 10 times x to the 9th. Now, let's try the second example. We want to find the derivative of g of x equals 1 over x to the 7th. Before applying the power rule, we need to rewrite this function. 1 over x to the 7th is x to the negative 7. Now we apply the power rule to this function. The exponent is negative 7. Step 1, bring the exponent to the front as the coefficient. That gives us negative 7. Step 2, we need to find the new exponent. So the new exponent is the original exponent minus 1. Negative 7 minus 1 is negative 8. So we have negative 7x to the negative 8. So the derivative becomes negative 7 times x to the negative 8. If we want, we can rewrite this with positive exponents again. Since x to the negative 8 is 1 over x to the 8, so we can write it as negative 7 over x to the 8. So the final answer is negative 7 over x to the 8. So far, we introduced two very important differentiation rules. The constant rule, which says the derivative of a constant is 0. The power rule, which says if f of x equals x to the n, then f prime of x equals n times x to the n minus 1. These rules allow us to find derivatives quickly and efficiently without using the limit definition every time. Now that we understand the constant rule and the power rule, we are going to learn three more important differentiation rules. These rules help us take derivatives when functions are added together, subtracted, or multiplied by a constant. This section is called sum, difference, and constant multiple rules. Let's start with the sum rule. Suppose we have two differentiable functions called f of x and g of x. The sum rule tells us what happened when we take the derivative of two functions that are added together. The rule says the derivative of f of x plus g of x is equal to f prime of x plus g prime of x. In other words, the derivative of the sum of two functions is equal to the sum of their derivatives. So the idea is very simple. If two functions are being added, we can just take the derivative of each function separately and then add the results. Next, we have the difference rule. This rule is very similar to the sum rule, but now the function is being subtracted. The rule says the derivative of f of x minus g of x is equal to f prime of x minus g prime of x. So the derivative of the difference of two functions is equal to the difference of their derivatives. Again, the process is simple. We take the derivative of each function separately, and then we subtract the results. Now, let's talk about constant multiple rule. Suppose we have a constant k multiplied by a function f of x. The rule tells us that the derivative of k times f of x is equal to k times the derivative of f of x. In mathematical notation, we write the derivative of k times f of x is k times f prime of x. This means that the constant simply stays in front and we take the derivative of the function. So the constant does not disappear. Instead, it just stays in front of the derivative. Now, let's apply these rules to an example. We want to take the derivative of the function f of x equals 2x to the fifth plus 7. Notice that this function has two terms, 2x to the fifth and 7. So we will use the sum rule. The sum rule tells us we can take the derivative of each term separately. So we have f prime of x equals the derivative of 2x to the fifth plus the derivative of 7. Now, let's find the derivative of 2x to the fifth. Here, we use two rules. the constant multiple, and the power rule. The constant multiple tells us the 2 stays in front. So the derivative of 2x to the 5th is 2 times the derivative of x to the 5th. Next, we take the derivative of 7. 7 is a constant, so we use the constant rule. The derivative of a constant is 0. So the derivative of 7 is 0. Then we are taking the derivative of x to the 5th. We are using the power rule. So the derivative of x to the 5th is 5 times x to the 5 minus 1. So we have 2 times the derivative of x to the 5th plus 0. 2 times 5 is 10, and 5 minus 1 is 4. And since adding 0 does not change anything, so the final answer is 10 times x to the 4th. So my derivative is 10 times x to the 4th. We learned 3 new differentiation rules. The sum rule, which says the derivative of a sum is the sum of derivatives. The difference rule, which says the derivative of a difference is the difference of the derivatives. And the constant multiple rule, which says a constant can stay in front while we take the derivative. These rules allow us to break complicated functions into smaller, easier pieces and differentiate each part.